Hello everyone. Welcome to engineering mechanics tutorials. Today now we are going to discuss about again how to apply the Lamy's theorem by analyzing the free body diagram here. Okay, in this problem two cylinders PQ are given and which are resting in a channel as shown in figure here. So the cylinder P has a diameter of 100 mm and its weight is 200 newtons, and where the Q cylinder has the diameter of 180 mm and weighs 500 newtons, and here the width of the channel, the bottom width of the channel is given as 180 mm, and the vertical side, that is the inclined side, is inclined at an angle of 60 degrees. Then we have to represent the, we need to find out the pressures at all the 4 points of the contact. Okay na? So with respect to this point, I want to first represent the free body diagram for P here. Okay, at each and every contact point, at what are the forces going to act, what are the forces are acting at each and every contact in between the channel as well as the two rollers or two spheres, we need to find out, okay, by analyzing the free body diagram here. So first I want to represent the free body diagram of P sphere. So when the P is contacting this channel surface, so here certain reaction force will be applied by the channel wall, so that I have represented with an arrow mark here. And here again it is in contact with the roller, so at this contact point also the certain reaction force will be applied to the sphere P. So this arrow mark represents the reaction applied by the roller Q on P. So remaining diagram I have represented with dashed line. This is required for analyzing, for solving the problem here. So again I am representing the same distance, 180 mm is the width of the channel is given. Okay, so next the angle of inclination is 60 degrees. Okay, this is the free body diagram I am showing, and again the center points A and B, and I have drawn this vertical line from the center point of the A, and from the center point of the B again vertical line, and a horizontal line from B point. So why I have drawn all these lines means during finding the forces, these distances we need to find out. So that means when you are representing all these reaction forces as the three kinds of the forces which are convenient to apply the Lamy's theorem, in that condition we need to know the angle of inclination between the two forces. So for that we need these vertical lines, so further you can understand. So I have given a name for the intersecting points as F, E and G, and R1 is the reaction force at this point and R2 is the reaction force at this point on the P sphere. So next, so I am considering the sphere P. So for that I have taken this center point here. So I have represented the R1 direction from this center point, next R2 direction from this center point, next weight of the sphere is also acting vertically downwards direction 200 newtons. So from this point you need to represent vertically downward direction 200 newtons. So this is the way of representation of three forces which are acting on the ball, that is sphere P. So here we have to know, so in this condition we have to find out what is R1 and what is R2. For finding R1 and R2 we can apply the Lamy's theorem. So before application of the Lamy's theorem we need to know what are the angles between the two each forces. Okay, so R1, the angle between R1 and 200, directly we can know that 90 degrees. Then what about this one and what about this angle? So go through this. So I have drawn a horizontal line here. So this R2 inclination with this horizontal line we need to find out. For finding that, if you know this R2 is same, R2 is same, and the horizontal line and the horizontal line. If you find an angle ABG in between angle, the angle of ABG, if you find out, that angle of ABG can be equal to the angle of inclination of this R2 with respect to the horizontal line. Okay, so for that we need to consider the right angle triangle ABG. Okay, so in that we need to apply cos ABG. Cos ABG is equal to, we can write it as adjacent by opponent. So that is BG by AB, we can write it as BG by AB, or BA we can write it as. So in this again, whatever the information, whether it is BG is known, no we don't know the BG, we need to find out, and the BA is known, it is unknown, but we can analyze by analyzing the free body diagram we can find out the BA. So the BA is equal to sum of the radius of this larger sphere and the radius of the smaller sphere. So here the diameter of the larger sphere is 180, so radius will be equal to 90. Similarly, diameter of the smaller sphere, that is P, is 100 mm, then the radius will be 50. So sum of these two radius will give you the distance, that is AB distance. So AB or BA is over. Next we need to find out the BG. So for finding the BG, what we do means the BG is equal to, can be written as CD, total CD distance. For finding this BG can be equal to FE again. So this FE or BG can be equal to CD minus CF minus ED or DE. Okay, now total distance minus this distance and this distance will give you FE, or ultimately which is equal to BG only. So this is the equation. Okay, in this condition again we need to analyze whether CD is known or CF is known or ED is known. So again CD already we know that 180 and CF is unknown and ED is 50. I have written. Why I have written 50 means ED can be equal to the radius of the smaller sphere, that is P. Why? Because it is a vertical line from the center point of the smaller sphere which is parallel to this wall of the channel. So automatically this distance can be equal to this distance only. That means the radius of the sphere, smaller sphere, can be equal to ED distance. So that's why I have written 50. Okay, now in this again we need to know the CF. So for finding CF, again consider one right angle triangle BCF. Okay, now so in this right angle triangle BCF, cot BCF is equal to, we can write, this is the right angle triangle BCF. So cot BCF is equal to adjacent CF by opponent BF. Okay, now so CF by BF we have written. So in this we need to find CF is equal to BF cot 60. So what is BF again? So again keenly observe, if you carefully observe the diagram, BF can be equal to the radius of the larger sphere, that is 180 is the diameter, then the radius will be 90 degrees. So 90 cot 60 will give you the distance of CF 52. So now substitute this 52 in this BG equation, then we can find out the BG value. So next slide, BG is equal to 180 minus CF minus 50. So this CF we got as 52. So substitute here. So automatically we will be getting the BG distance 78. So now we can go for cos ABG, that is angle of ABG is equal to 78 by 140. Okay, 78 by 140. Why it is 140? 78 by 140. So why it is 78 by 140 means here, so BG by B already you have determined in the previous slide. So we go for previous slide again. So already you got B as 140. Okay, now that is the sum of the two radius of the two spheres. So that's why we can write it as cos ABG is equal to 78 by 140. So now angle ABG is equal to automatically cos inverse of 78 by 140. By using calculus we can get the angle as 56.1 degrees. So that means here this angle is the R2 inclination with the horizontal line is 56.1 degrees. Okay, now so if it is 56.1 degrees, so total angle is 180 degrees from R1 to this horizontal line. So 180 minus 56.1 degrees on this line diagram, the angle will be getting 123.9. So we know all the angles in between the two each of the two forces. So now we can apply the Lamy's theorem. So apply the Lamy's theorem. So R1 by opposite angle, sine of the opposite angle, R1 by sine of opposite angle is 90 plus 56.1. Similarly, R2 by sine of opposite angle, R2 by opposite angle is 90 degrees, and 200 weight of the sphere, 200 by sine of opposite angle is sine of 123.9. So modifying again we'll be getting like this, 90 sine 90 plus theta, again sine theta. So 123.9, we can write it as 180 point something. Otherwise by using calci we can write the value as it is. So next we go for same line, R1 by sine of 56.1, R2 by sine 90, 200 by sine of 123.9. So for finding R1, take the two terms, this term and last term, then make it R1 is equal to, then simplify this equation by using the calci, automatically you will be getting the R1 as 134.2 newtons. Similarly, go for the remaining two ratios for finding the R2. Okay, na? So R2 is equal to, take the sine 90 to the right side. Okay, so simplify the equation by using calci, again you will be getting the R2 value. Okay, now these are the two reaction forces acting on a sphere small P here. So next we go for free body diagram of the roller second sphere. So for that, here this is the second sphere free body diagram, on which here certain reaction force will be acting, which is already equal to R2, and here another reaction force will be applied by the inclined wall, that is the cylinder, sorry, channel wall, acting perpendicular to it, and another reaction force will be acting at this contact point here. And before that, I have represented the weight of the sphere as 500 newtons, which is given in the problem. So wherever the contact is taking place, here certain reaction force will be acting. So now we try to draw the line diagram. So this R2 is equal to, already we got it as 240.8. Okay, now before this slide we have determined the value R2, and the next line is represent the R3, and next line represents the resultant force of these two forces in upward direction, R4 minus 500. So the resultant force will be here, the resultant of two forces will be automatically R4 minus 500. Okay, that will be acting downward. So when it is acting downward means certain reaction force will be acting upward only. So total resultant reacting force, that is R4 minus 500, will be acting in upward direction only. So next we have to know again the angle. So this angle is 30 degrees. Why it is angle 30 degrees means here, so this R3 making an angle with the horizontal line. Here when you extend this one, okay, so this is 90 and this is 60 is given already. So 180 minus 90 minus 60 will give you again 30 degrees. So automatically with the horizontal line, R3 makes an angle of 30 degrees. So this total again R4 with the horizontal line is 90 degrees. So 90 minus 30 will give you 60. That is an angle of inclination in between R4 and R3. So next it is 90 degrees only. Next it is 56.1 degrees, which is the R2 making an angle with the horizontal line, which is derived in the previous analysis. So now this total angle also we can calculate this side. 30 plus 90 will give you the total angle here. Okay, we can write by application of the Lamy's theorem. So I am applying the Lamy's theorem. R3 by opposite angle will be R3 by sine of sum of these two angles, 90 plus 56.1. Similarly 240 R2, that is 240.8 by opposite angle, sine of opposite angle is 60. And similarly R4 minus 500 by the sine of opposite angle is sine of 180 minus 56.1 plus 30. Why? Because this total angle is 180. So 180 minus 56.1 and plus 30 degrees. Then we will be getting the total angle between the R3 and R2, that is 240.8 newtons. Okay, na? So this is the way of applying the Lamy's theorem to the second sphere. So now simplify the equation. Okay, na? Sin 90 plus theta cos theta, sin 60 sin 16. So here by subtracting each and every term, you will be getting 26.1. Okay, so now for finding R3, take these two terms, first two terms. R3 is equal to 240.8 into or 240 into cos 56.1 by sin 60, we can write it as. So by simplifying by using calci, we can get the value as 155 newtons. And similarly for finding R4, take these two second ratios. So R4 minus 500 is equal to 240.8 into sine of 26.1 by sin 60. Okay, so now take R4 minus 500 is equal to 122.3. By simplification we'll get this value by using calci. So now again make it R4 is equal to, when you take the 500 to the right side, you need to add it to the 122.3. So then we'll be getting 622.3 newtons. Okay, this is the way of applying the Lamy's theorem whenever the two spheres are given in a particular container or any other channel by drawing the free body diagrams. So the analysis of the free body diagram is very important. So after getting the analyzed free body diagram, we need to apply the Lamy's theorem for getting the unknown values, that is the reaction forces applied on the sphere. So I hope you understand how to apply the Lamy's theorem whenever the free body diagram is to be obtained for a given condition. So if you have still any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. And once again, thanks for watching my video. Thank you all.